of the presentation is the case for water mist for large data center applications. Large data center applications. This is going to be another big boom, I think, to our industry. There's going to be with the advent of AI, machine learning. There's going to be a whole new influx of new data centers being constructed. And some of these data centers, I'm told, are like $1 billion projects. So there's a lot of opportunity for all of us, both in engineering and in contracting. Okay. All right. So some of the learning objectives today is the phenomenon of pyrolysis. What is that? I think it's important to understand that with regard to water mist systems. What is water mist and how does it work? What makes water mist systems effective? The benefits and disadvantages of water mist, the applicable codes and standards, water mist system types and design approaches. And by the way, since we have such a few number of people, if you have a question, just kind of like blurt it out, okay? And we'll handle it as we go, because if you wait to the end, you're probably going to forget the question. So very informal, just kind of blurt out your question as we go, and I'll answer them as we go. So I'm Frank Savino, president of United Fire. We started in 1988. We're about close to 200 employees. I got 47 years experience in the business. I'm a principal member of NFPA 72, the National Fire Protection Alarm and Signaling Code Technical Committee, and I hold various fire alarm and suppression contractor licenses in multiple states. The disclaimer, I do not represent the NFPA as part of this presentation, either their opinions or any other matters related to NFPA. The opinions and everything I'm saying are strictly my own. So about United Fire, again, we're one of the largest, most well-known full-service fire protections in the New York metro area. Our main office is in Kenilworth, New Jersey, right outside of New York City. We have a branch office in Farmingdale, New York. Our manufacturing, we do manufacture products, is in Union, New Jersey, and our branch in Florida is called Frontier Fire. The reason we're not United Fire is because there already is a United Fire in Florida before we started operations in Florida back in 2020 is when we started operations in Florida. So we have a lot of history with water mist in New York City, for example. We were the very first company that we designed and installed for major, clients, including the New York Stock Exchange, Con Edison, World Trade Center Transportation Hub, where all the PATH trains come in. That's all protected with a water mist system, all those tracks. We did the entire New York City 2nd Avenue subway line. We've done numerous banks and numerous landmark historic structures. Our goal, our mission is to be a high technology leader in the industry and offer the highest quality products and services to the marketplace. Okay, so the phenomenon of pyrolysis. The word pyrolysis, it comes from the word pyro, which means heat, and lys, which means breakdown. That's Greek terminology. So pyrolysis occurs on the surface of a solid fuel. So really what that means is that if you take a piece of solid material that's combustible, a piece of wood, a piece of cardboard, a piece of plastic, and you heat that solid material to between 570 degrees to 750 degrees Fahrenheit, it'll start to form gases, hot combustible gases, will off gas off the surface. Sometimes you can see that, if you take a piece of wood or a piece of cardboard or anything else that'll burn, you put it near a hot surface, you'll kind of see like smoke coming off of it, even though it's not burning. That smoke is actually combustible gases. If you combine that hot combustible gas with oxygen, which is in the air, and heat, you will get fire. So pyrolysis is it's kind of like a chain reaction. So you have heat and solid matter, which then creates gas, which in combination with heat and flame, a source of ignition, creates more heat, which then gasifies more gas, and you have this chain reaction, this self-perpetuating chain reaction known as fire. Okay, this depicts the phenomenon of pyrolysis with a short video. So it was pretty interesting. You saw the lampshade, which of course is solid, gasify, and then at a certain point in time, when it reaches its ignition temperature, it bursts into flames. So that is really what's happening, in all fires. Okay, whether they're liquids or solids or gases, it's the gases in conjunction with the oxygen and air that are necessary with heat to create combustion. All right. So what is water mist? Per NFPA 750, which is the standard that governs water mist, it's a very fine water spray such that 99% of the liquid volume is in smaller droplets of 1,000 microns diameter or less. So 1,000 microns is about 0.04 inches. Okay, most of the water mist systems actually create much smaller drops, and when you compare that to conventional sprinklers, most of the droplets in sprinklers are about 2,000 microns or bigger, which is 0.08 inches. And a lot of sprinkler systems create much larger drops, actually. Okay, so let's take a look at a sprinkler system, what it looks like. So that was a lot of water, probably somewhere in the order of like a zero point 0.2 or zero point 0.3 gallons per minute per square foot. And that was pretty impressive. That was a lot of water coming out of that sprinkler head. Let's take a look at what water mist looks like when it discharges.
So in that situation, the water mist was not fused heads. It was just open heads.
Yeah, those were open heads, and they could be open or they could be closed. The purpose of that video is just kind of to show what it looks like
Got it.
visually. So you
Mm-hmm.
could see a much finer spray versus a much larger droplet. That's the main differentiator.
Got it.
But, hold on a minute. Let's see now. Hold on. Okay.
But
Okay.
if you're using mist for occupancy, you 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 would want to have the automatic top nozzle that has the fusible leak in it, just like you would on a regular sprinkler system, because they were
That
holding that up, correct?
Yeah, that is correct. Normally, most water mist systems, and really, you really need to conceptualize water mist as being just like a sprinkler system. Okay, works the same way. Principally, you have wet type water mist systems, pre-action type, deluge type. Anything you could do pretty much with a sprinkler, you can do with mist. The main difference is in the size of the droplets and then the amount of water that you need to put the fire out or to design your system to. So, so how does water mist system work? It basically it cools the gas oxygen mixture which retards combustion. So if you look at the photo in the lower left, you'll see like a flame, a very large flame, but then you'll see water mist being discharged into that flame. So when it's discharged into the flames, it interacts with it in a way that the tiny water droplets will gasify to cool the flames. And so there's a flame inhibiting effect, okay? Also, the heat absorption turns the liquid water into vapor. And in that changing from liquid to vapor, it absorbs a tremendous amount of energy. The heat of vaporization of water is very, very high. So, for example, 1 gram of water, the latent heat of vaporization, in the process of turning from a liquid to a vapor or a gas, requires 540 calories. That is very, very high. When you compare that to other liquids, water, I think, is at the top of the list. So that is why water is such a great extinguishing agent. So the other thing that's very noteworthy, and this is really the key to water mist, is that if you look at the volumetric expansion is 760 to 1. So in other words, when liquid water turns into steam or vapor, it increases in volume 1,760 times. So by doing that, by that expansion, that steam displaces the oxygen right at the seat of the fire where that vaporization is happening, because you need the heat to vaporize it. So right at the seat of the fire, that tiny water droplet is turning from a liquid to a gas, expanding 1,760 times, and that basically starves the fire of oxygen, and it makes the combustion rate significantly decrease. So here's a water mist system protecting a transformer. So that was pretty impressive from the standpoint. You really see it's almost like a fogging effect. And the amount of water compared to, say, a water spray system is significantly less. And it did a really, really good job there of surrounding the fire, surrounding the object, and extinguishing it. So that is a really good depiction of
So that actually put out the oil fire on the transformer, or did it just knock it down to be controlled?
Okay. The requirements for Factory Mutual to get listings for water mist, unlike sprinklers, is that you must extinguish the fire. If you don't extinguish the fire, you do not pass, you do not get a listing. All of the water mist nozzles per Factory Mutual must extinguish the fire. There's no such thing as control or suppression to obtain a listing. So to answer your question, yes, that extinguished that fire.
Got it.
Okay, so other ways that water mist system works, I call it the birthday candle effect. It's the physical displacement of flames of gas away from the where the pyrolysis is happening. So when you discharge the water mist toward the fire, it's actually moving the heat and the flames away from the fire, taking away that heat source. That's another principle of operation. Also, the wetting and burning of adjacent surfaces. With water mist systems, despite what some people believe and what other people tell you, things do get wet, okay? So you can't think of water mist as like a clean agent where things are not going to get wet. Things are going to get wet with water mist, okay? So by wetting the adjacent surfaces, they're less likely to undergo their process of pyrolysis, all right? Because of the heat of vaporization required of the water when it coats that other burning material. Also, the water mist has a screening effect, so it's blocking the radiant heat so that adjacent surfaces are not subjected to the high heat of the fire. And also with the water mist, you're cooling the surface of what's burning to reduce the gas evolution or the pyrolysis. So again, the way it works, the creation of steam removes heat through the heat of vaporization principle, the displacement of the oxygen away from the fire through the production of steam. So why does that happen? Okay, well, because of the smaller water droplets, you have more effective heat transfer. Okay, so when you take a fixed volume of water and then you create smaller droplets with it, what you're really doing is you're increasing the surface area per unit volume. And really all transfer of heat happens at the surface. It doesn't happen in the middle. So when you're increasing the surface of area of the water, you're increasing its fire extinguishing potential. And when you think about it, if you look at a sprinkler system and it's discharging water, when it interacts with the burning material and it falls on the floor, the water, it's not doing anything when it's on the floor. So having it in a very tiny form where it could interact with the flame and fully coat the solid burning material, you're really using water in its most efficient way. So you're going to get faster cooling, faster vaporization, and expansion to steam. You get more water evaporating, less water wasted on the floor, and more steam generated. So the benefits, I say less is more. You got 50% to 75% less water needed versus sprinklers, less equipment and contents damage, less building flooding and damage, less cleanup, less downtime, less demand on a water supply, and less water containment and disposal necessary. Today there's a lot happening in the data center space. There's cybersecurity. Everything's gone to the cloud. You've got the Internet of Things. Power requirements are way up. Cooling requirements, as a consequence, are way up. And this is all being driven by AI, and which is going to be the next new industrial revolution in our country. Everybody's saying. So the thing to know about water mist is that it is application specific. Okay. So what that means, it's based on specific hazards and configurations. In order to get approval for a particular hazard, it's required that application is full scale fire tested. And unlike sprinklers, it's not a one size fits all. There are specific nozzles for specific hazards, and we're going to get into that shortly. Okay. Other thing is when you think back at that video that we saw of the water mist system discharge, it kind of looked a lot like a gas, kind of like a clean agent almost. Okay. But again, things do get wet. But the benefit of that is that it will more readily permeate inside of equipment enclosures. And it is somewhat like a total flooding performance. One of the things that's really a great benefit is that with water mist, you can use much smaller pipe sizes. So we had a job in Miami that originally was a big sprinkler job, and we took a look at it for the purpose of quoting it as a water mist system application, and it had like 1,500 heads. And what we observed when we designed it for water mist was all of the pipe sizes went down two pipe sizes. So 4-inch pipe became 2.5-inch pipe, 3-inch pipe became 1.5-inch pipe. Everything came down 1.5 pipe sizes. So that translates into reduced structural load, less installation time, and space saving. So what are some special piping requirements? For that, you have to go look at NFPA 750, section 6.3. That you need to have corrosion resistance. They have a table there, 6.331. So really what it boils down, there's a lot of different options, but it comes down to stainless steel or seamless copper. We kind of concluded based on our analysis of costs and everything else that really either 304L or 316 stainless steel was the best option. So joining methods, you can be threaded, you can use compression. The nice thing about tubing, if you use tubing, is that you can bend it. Carbon steel, black, or galvanized pipe is not permitted. I wanted to share for the benefit of JLRD. They do a lot of hospital work. We're talking a lot about data centers today, but JLRD is a lot done for hospitals and healthcare. A couple of years ago, we had a customer that was a facility that did ambulatory surgery. It was an eye hospital, and they were governed. It was a job in New Jersey. They were governed by NFPA 101 Life Safety Code, which is a federal adopted standard, which is also adopted in Florida, by the way. And they were required to fully sprinkler their building. It was about a 10,000 square foot building, roughly, and they were on a state highway, and it had a large parking lot, and they needed a minimum 3-inch water supply to feed their sprinkler system, and they didn't have that. So in order to bring a 3-inch water supply into the building, they had to dig up the parking lot and dig up the state highway, which is a major to do here in New Jersey, to dig up a state highway. Probably is the same case, anywhere. So we looked at their domestic water, and they had a 2-inch domestic feed. So we ran some calculations, and we found that we could make that 2-inch work with a water mist system. So we designed the entire system for a light hazard occupancy with water mist. And we were also able to use CPVC pipe, which was approved for this application because they had a hung ceiling and it was light hazard. So we did the job.
Like Blaze Master?
Yes, we used the Blaze Master, correct. Yeah. So we did the entire project with the Blaze Master pipe with water mist nozzles, and we got the 2-inch domestic to work. I should note, though, that they didn't have enough pressure to support the water mist system, so we did have to put in a fire pump. We used a regular standard centrifugal fire pump for the application. We did learn some lessons because we said, we'll just do a fire pump. But when we got into the design, there was really no place to put the fire pump. Okay, every part of the building was for operations and other uses. So we had to end up taking part of the customer's waiting area, which they weren't too happy about, but it was the best that we can do. So we took about a 10 by 10 area out of their waiting area, and then we had to build a special room in accordance with NFPA requirements for fire rating of the walls, et cetera. And the other thing that was a little bit of a hassle and expense was the electrical power supply requirements for an electric pump. Has to be tapped ahead of the main breaker. So we had it, that got a little bit expensive. But overall, it was a good application for water mist, where you had an application where you didn't have the water supply for sprinklers, but we had it for water mist. So I just share that story with you, especially for JLRD. They do a lot in the healthcare industry. And you can really apply this to any situation where you don't have the water supply to support a sprinkler. You can do a water mist system, including if you don't even have any city water at all. With water mist systems, you can have your own water tank, which is another option. And I'll get into that shortly.
And you can also do the gas-powered units also, where you have.
Yes. Yeah. In other words, they have some systems that are powered with compressed air cylinders.
Yeah, they're nitrogen.
Yes, exactly. Or just compressed air. So the different types of water mist, as defined in NFPA 750, high pressure is above 500 PSI. Intermediate pressure water mist is 175 to 500, and low pressure is anything under 175. The water supply requirements, you can tap off your city water supply. You can do a city water supply plus a pump, as I described in that medical facility. And then you also have the option, if you don't have any water at all, to do a stored water tank. And that's where water mist really comes into play. And you'll see what I mean by that in a minute. Okay, so with water mist, you really get more for the money. Low pressure water mist is comparable in overall cost to sprinklers. With stainless steel pipe and tubing means you really don't have much of a corrosion issue like you have with carbon steel pipe. Smaller pipe means lower material costs. The stainless is more expensive than carbon steel, but the lower sizes offsets that. And I believe that the numerous benefits, especially for a large data center application, outweighs any incremental cost differential. That project in Miami I was telling you about, it was like our contract was like a $1.5 million contract. When I modeled it for water mist, it was about $150,000 more, although I should say I did not give the customer a credit for the labor, which there may have been. It might have been a wash, but even that incremental cost, in my opinion, for all practical purposes, it's about the same. For the added benefits you get, I think it's worth a couple extra dollars, but it's not like double or triple or anything like that. It's incrementally more expensive, but not much. You have the environmental benefits, sustainability. That's the buzzword today, especially in the data center environment. We're not using any chemicals. There's less water to clean up. There's smaller containment requirements when necessary, such as in lithium-ion applications. And there's less of demand on the water supply. And we're going to get into that in a minute. Okay, some of the disadvantages, you will need a fire pump most of the time, because most of the time, even for a low pressure water mist system, you're dealing with minimum about 120 PSI is what you need, to all your nozzles. And you're going to probably do a little more than that, to account for friction loss, et cetera. So, excuse me. So, but with low pressure, you can use a conventional centrifugal pump with relatively low GPM capacity. There are a maximum ceiling height for some of the hazards, like in data halls, 25 feet. And you do need attention to design and engineering. People that are just in the sprinkler business, they really would need to be trained. So this is really more of a special hazard kind of a design.
What are your thoughts on areas where you've got hot aisle containment with the big openings in the suspended ceiling, and you got to put sprinklers above and below the ceiling? Would you put mist above and below? Would you put pre-action sprinkler above and mist below? What is the thought behind that?
Hey, Jeff? Is Jeff still with us?
Yeah, I'm here.
What is your thought on that, Jeff?
If you're going to use it in the room, I would use it above the ceiling as well in that application. Yeah.
I guess you'd follow the same rules as sprinkler rule, correct, Jeff?
Yeah. Yeah,
Okay.
we've done data centers with regular pre-action sprinkler that are set up like he's describing, where you have, because of the containment there, you end up needing to protect the above ceiling because it's open. So yeah, if you were using water mist in the room, I would use it above the ceiling there too.
And so do
Okay.
you end up having to put it over the entire ceiling, just like you would have to put it in the entire or below the entire ceiling. Am I
Yeah,
correct?
it would follow the same layout. Yeah, it would be very similar to the pre-action sprinkler, just with water mist instead. You would have to do the whole above ceiling there.
And so there's no, it would be like in a 3 or 4 foot cavity. And so mist would operate just as well in that environment as it would is in the room itself.
Yes, yeah, I believe it would.
Okay.
Okay. So some additional disadvantage. By the way, Jeff is going to have to leave soon, so I'm going to be on my own after that. Thank you, Jeff, for that. So some additional disadvantage, some of the disadvantages. So smaller droplets can more easily be shifted off target by horizontal and vertical upward airflow. So there are limitations in terms of horizontal airflow that you need to be attentive to with regard to water mist, as you also have to do with sprinklers also. So the smaller droplets are more easily shifted off target by, say, horizontal airflow. Small droplets are not effective at as effective as penetrating a high intensity, very large fire plume. They may get blown up, okay? But if they're going into a fire plume, they're going to gasify and they're going to start cooling it, and then other droplets are going to come in behind it to penetrate to the seat of the fire. And the other thing is some of the disadvantages are also offset by the higher pressure and high velocity of that a lot of water mist systems have to penetrate. So what are some of the codes and standards that are applicable to water mist system and data centers? NFPA 750 is a standard for water mist system. It gets into the minimum design requirements for design, installation, maintenance, and testing. They don't really, NFPA 750 doesn't really provide definitive performance criteria. It really, it is very general, and it really puts reliance on, systems that are part of a listed product with full-scale fire testing. It's very general and generic. You're not going to find a lot of specific guidance other than things like the type of piping requirements that we talked about earlier. NFPA 13, the standard for sprinkler systems, is referenced by NFPA 750. And it's really kind of like the default standard. If 750 doesn't address something, the default is you go back to 13 and say, hey, what does 13 say about that? NFPA 20 is a standard for fire pumps that applies to water mist systems. All the rules that govern fire pumps are there. NFPA 25 is a standard for inspection, test, and maintenance of water-based systems. That also applies to water mist systems. NFPA 75, a standard for protection of information and technology equipment, has very general fire protection guidance for data center, but it does recognize water mist as an acceptable solution. NFPA 855 is a standard for the installation of stationary energy storage systems. And that's applicable to lithium-ion energy storage systems. Additional standards are NFPA 5560. That's really the Bible, NFPA 5560. It's titled Examination Standard for Water Mist Systems, and it governs test protocols and performance requirements to get FM approval. And it has specific test requirements. And by the way, you can find the FM standards right online. If you just Google Factory Mutual F50 standard 5560, you'll find it very easily, okay? So it'll tell you all the different test requirements for the different, what they call appendices. So for example, data centers up to 15 feet in height is Appendix M. It describes them, describes the hazard, but more importantly, it describes the test that somebody who wants to get a listing or approval, the test that has to be passed, okay? So that's right there in Appendix M. For subfloors, Appendix N. For machinery spaces like emergency generators, turbines, it's Appendix A, C, E, and that depends on the volume of that space. That would also apply to, say, an elevator machine room or utility gas turbine would be covered in machinery spaces. Non-storage occupancy, hazard category HC1, which you also know as light hazard, is Appendix G, and then hazard categories HC2 and HC3, which would be ordinary hazard, and extra hazard is in Appendix I. So Appendix P, excuse me. So looking in there in that standard 5560, you'll see the test criteria and you'll have the definitions for the different hazard that are recognized. Factory Mutual also has data sheet 4-02 on water mist systems. Was there a question?
Okay. No, I was saying, yeah, that's for standard water mist.
Right. Yeah. So that's kind of general, like data sheet 4-02. It's very general guidance. And within that, though, it does recognize data processing rooms as an applicable hazard in 40402. But really, the meat and potatoes of water mist is in 5560. Data sheet 5-32, titled Data Centers and Related Facilities. It provides design guidance, and it has everything from material of construction and spacing between equipment and, issues regarding lithium-ion batteries, in server racks is described in 5-32. So really, the takeaway of all this, all these different codes and standards, is Factory Mutual is really the only U.S. standard-making organization with water mist full-scale, hazard-specific fire test protocols and full product-specific equipment approvals. So that's really where you have to go. You're not going to find it anywhere else. So that's where you have to go. And all the applicable codes and standards like the UCC, NFPA standards, it refers to equipment that is listed. So listed means tested by a nationally recognized laboratory, which FM, Factory Mutual is, that is acceptable to the authority having jurisdiction. So really what I'm saying is Factory Mutual is it, okay, with regard to water mist systems. Okay, UL, has a really minor role, almost insignificant. They do have listings, but they just have like equipment approvals. Like they'll say, okay, this nozzle passes the UL test for corrosion or the drop test. It's almost like not even worth paying much attention to. They have a very minor role in the approval making process. So typical nozzles, these are high pressure water mist nozzles. This is what they look like, some of the characteristics. So if you look at the nozzle all the way to the left, that's a closed head nozzle. So that orange thing that you see there, that's the frangible element that heats up in a fire and then it breaks. And what happens is the water is discharged through these tiny jets that I'm pointing to here. I don't know if you see that. So there's probably like 6 jets on that. And so the water mist comes out at a very high pressure out of those jets. Normally with a high pressure water mist system, you need what's called a positive displacement pump. That's depicted all the way to the right. And they usually require quite a lot of power compared to a low pressure water mist system, 3 to 5 times more power. And the cost for a high pressure is typically higher. And what I found is really there's not much of a benefit to high pressure because the water densities are about the same as low pressure. So I don't really see much of an advantage. What you see in the middle here, that is an open nozzle that you would use, say, for a machinery space, like an emergency generator. Okay, these are some low pressure mist nozzles that you see here. Typically, you also have that orange fusible element all the way that I'm pointing to here. That's the part that breaks in the water. It's a single orifice with a diffuser on this particular arrangement here. Very similar to a regular sprinkler head. What you see at the top here is a screen that's designed to prevent any particulate matter from blocking the orifice of the nozzle. And that's one thing with water mist systems, being that you have smaller orifice, that you have to really pay attention to, and that's filtering the water to prevent an orifice from being clogged. So the requirement on every single nozzle to get approval is to have that filter, but then there's also requirements upstream of that at the valve, at the water source. You need to be filtering the water and screening out particulate matter there. And and when you think back at that high pressure, how it had tiny orifices. Okay, this is an open nozzle that you see here. These are actually more susceptible to getting clogged. So in the design process, I can't overemphasize enough the importance of making sure that your water quality is clean and filtered. See now, okay. So, and sometimes, a pump is not required. If you've got, say you got a city water coming into a building and you have 140, 150 PSI of city pressure, you can do a water mist system without even a pump. So, in fact, we did a survey not long ago just to get an idea, and I think we found somewhere around 25% of the time. We just kind of looked at the static pressure in the buildings that we service, and 25% of the time they had enough water pressure just from the city to do a water mist system. So you would not even need a pump. So you can do a vertical or horizontal pump, centrifugal pump for a low pressure system. And again, a centrifugal pump consumes about 60 to 80% less electric power than a high pressure pump. You can do skidded or not skidded. So these are all skidded assemblies. So what that means is that you've got here on the depiction all the way to the left, you've got a horizontal pump, and a motor with your fire pump controller. And you've got your jockey pump controller, and then you even have your pre-action control panel, like all pre-assembled on one skid. You can do that, or you can have these separate components. You can put your fire alarm control panel and your fire pump controller on the wall, and you can put your fire pump and your motor on a pedestal. So you can go either way on that and treat it just like a regular sprinkler system. But this is a really informative chart that you see, table that you see here. So let's take a look at it. This is for data halls, okay? So the typical density, gallons per minute per square foot is 0.08 on a water mist system. That's a closed head system. Your design area, which is 6 nozzles, would be 864 square feet for 6 nozzles. Your total GPM flow for those 6 nozzles is 70 gallons per minute, and over 60 minutes, which is the required duration, you would have to allow for a total flow. And if you're going to collect water, of 4,200 gallons, or if you're going to have a water tank, you would need 4,200 gallons of water in a tank. Let's compare that to sprinklers. Okay, NFPA 13 for a data center. You're looking at a 0.15 density. Your design area is 1,500 square feet. That translates to 225 gallons a minute. So for 60 minutes, 13,500 gallons. The factory mutual requirement, and a lot of these big data centers are factory mutual, 0.2 density, design area 2,500, which translates to 500 gallons a minute. 60 minutes of flow is 30,000 gallons. So let's look at this table on the bottom. So water mist, 4,200, NFPA 13,500. Look at FM, 30,000. That's 7 times more water versus water mist. So that really graphically illustrates a significant difference between what you can do with water mist versus sprinklers. And again, factory mutual would have no problem with a water mist. If you said, hey, you know what, we're going to put water mist in accordance with FM standards in this data center, they say, great, just follow our guidelines. And AHAs feel the same way. We've done many, many water mist systems. They consider water mist systems to be an approved, acceptable fire suppression system that's gone through all the testing to prove its efficacy and effectiveness. Any questions on that? Okay, moving on. So again, we have application specific versus prescriptive. Sprinklers, in NFPA 13, the discharge densities are pretty much arbitrary. They go all the way back to pipe schedule days, and they really haven't changed much. They're not performance-based. They're not based on full-scale fire testing, and they're usually intended for control only. Whereas water mist systems and the FM approval 5560 standard, they're approved for specific hazards. They have to perform specific requirements. And again, the most important thing, they have to pass the full scale fire test. The fire has to be extinguished. Individual dependencies for each different application. So it's very, very specific. Just to review, for data halls, it's Appendix M. That's for ceiling heights up to 15 feet. Data hall, Appendix P, ceiling height up to 25 feet. And you can include under Appendix P, a lot of these in-racks have built-in lithium-ion batteries. You can use water mist for that application.
Yeah, but water mist isn't going to put out a lithium-ion fire. So,
Right.
you started out with you're approved to use this to put the fire only if it's puts the fire out, but you can't put out a lithium-ion fire with water. So
well,
that's a bit of a contradiction.
I think, you know what? Yeah, I think that's a good point. I would have to look and see what their pass-fail criteria is. It might be that within that requirement, there may be, and I believe that there is, and you should probably refer to Appendix P, there are going to be requirements for spacing. If you have lithium-ion batteries in racks, spacing between racks are probably going to be a requirement. We could look into that. But
well, there's the 9548 testing
Right.
that allows you to put them next to each other, right? So as long as you're below the 600 megawatt hours in a room, you're meeting the requirement, and you can put them next to each other. So it's just something that you need to get into.
The Appendix P approval, it literally came out about a month ago. The very first Appendix P approval for this application. So I have to confess, I'm not 100% familiar with it, but I know it does exist. So what I'm going to do, Steve, I'm going to look into that, okay, further with the manufacturer and the testing that they did to determine what the pass-fail criteria was and what the requirements are. I'll get back to you on that, okay?
Great. Mm-hmm.
Okay. Subfloors, Appendix N, emergency generators, ACE, mechanical, electrical equipment rooms, so your high voltage electrical rooms, Appendix G, UPS battery rooms, Appendix P, like we said, and there is a local application also for, say, machinery spaces. You can do either total flood or local application with water mist. Local application means that you're discharging the water mist right onto the hazard areas that are expected to burn.
Like equipment.
Yes. So lithium ion energy storage systems. So again, the relevant documents, FM 5-32, 533. Now this, we're talking about here centralized lithium ion batteries. The Uniform Construction Code, which is adopted by most states, has a requirement of a 0.3 gallons per minute density over 2,500 square feet. Factory mutual requirement is 0.3 over the entire room. Right now, there is no factory mutual appendix for this hazard, for battery energy storage rooms, central storage. NFPA 13 does not specifically address this yet. And NFPA 855 reiterates that no specific water mist testing standard exists. Hey, Steve, what was that other standard that you were referring to when we were talking about rack storage? There was you referenced some other standard. Was that a
It
UL
wasn't.
stand?
It wasn't rack storage. I mean, I wasn't talking rack storage. I
I
was
mean,
just talking NFPA
servers,
55.
servers with batteries within it.
Oh,
Was it 95 something?
so
9540A.
9540A is for UPS or for lithium ion battery cabinets. Not
Okay.
necessarily for IT racks with batteries in them. It's
Okay.
just relative to all different kinds of batteries and battery storage within rooms.
Now, is 9540, is that an FM standard or UL? What is
No,
that?
it's a UL. It's a UL
Oh.
testing requirement for the battery cabinet.
Okay. All right. Let me
So
look
it's
into it.
9540, and the 9540A is the testing requirement.
Gotcha.
So if the cabinet meets 9540A, then you can avoid the spacings required in NFPA 55.
Okay. Okay. So right now we're talking about what you see on your screen, centrally stored lithium ion batteries. There's certain requirements on that. Okay. And there is no water mist standard approval for that hazard.
Mhm.
But so UCC is 0.3, FM is also 0.3, just the density is different. So this is lithium ion battery. Basically, this refers to in-rack lithium ion. So you've got it right within your server rack. So this basically is saying you have to have less than 20 kilowatt hours per rack. That's where your water mist approval restriction is. No more than 20 kilowatt hours per rack and no more than 2 shelves with batteries per rack. Then your 5560 Appendix P can be used. But if you have more than 20 kilowatts in a rack or more than 2 shelves, you cannot apply Appendix P of 5560.
And when you have so I guess we're saying that you can dump mist and leave the power on because and you're not going to damage the IT equipment.
Well, you know what? I'm not going to say that because again, don't forget things are going to get wet, okay? And you're going to have smoke, you're going to have heat, you're going to have enough heat to activate a 100 and whether it's 35, yeah.
But what it comes down to is it's usually one rack that catches on fire,
right,
underneath one sprinkler head, hopefully.
Yes.
And so you're dumping water in a small area.
Correct. So your expectation is the rest of the room is going to be okay.
Yeah.
Okay.
But Steve, isn't that the under 20 kW per rack? Wouldn't that be for lithium? But if you were doing like the lead acid, wouldn't it be more than that
You'd
per
never
rack?
put lead acid in the rack. It's
Okay.
just it's too big to get
Okay.
the power you need. You need the rack. The batteries
Yeah.
would be bigger than the rack.
Yeah.
So, and they're only doing like 1 minute of battery when they put these batteries in the rack.
Right.
So if it's a 20 kW rack for 1 minute, it's 20 kW for 60 seconds as opposed to 20 kW per hour. So it's well under the requirement that they've got.
Right. So the Appendix P nozzles can protect up to 25 feet. And the other thing that's noteworthy is like one pump for sprinklers and the mist. So in other words, if you have essentially stored battery energy storage system and you got to put sprinklers in there to get the 0.3 density and the rest of your building is going to be water mist, you can just size your pump to deliver the GPM that you need, but also the pressure that you need. So you can have a hybrid system where you've got sprinklers in some areas and water mist in other areas. That's the key point here. Okay, summary and conclusion. So you have NFPA, Factory Mutual 5560 and NFPA 7750 approves water mist. It's very efficient, 50 to 75% less water. It's effective, proven by actual hazard testing. Versatile, you can do just about the whole data center complex. It's sustainable with regard to environmental issues. And really, it's the latest state-of-the-art fire protection for large data centers. Integration is very important. Your field surveys, your detection, control, notification, enunciation, interfacing with BMS, HVAC. So that's all part of an integrated overall fire protection solution. It's not just a water mist, it's other parts of the fire protection solution that goes along with it. All brought to you by United Fire Protection. We can help you with any water mist application. We could do like design drawings. We do pre-bids for engineers. So you let us know and we'll lay something out like we're going to do for that stock exchange right now. We're working on that. Any questions?
I think you've answered them as we moved along.
Yeah. So just a little shameless plug. This is our pre-action pack cabinet. It's FM approved as an assembly. And by the way, it's the only approved unit right now with an addressable control panel option. Okay. So we have like the Notifier 640. We've got the Potter addressable panel. We have conventional panels. We have the Kita panel. So you can integrate pre-action with clean agent. And we also have integrate nitrogen with that too.
That was about to be my next question. So it's similar to the total pack that Viking has.
Similar, but it's better because we can put an addressable control panel. In my mind, I would never use anything less than an addressable system for a pre-action system or any system, even a little, strip mall. I would use an addressable system. I would never, use a conventional fire detection alarm system for many reasons, such as point ID, history buffers, maintenance alert, things like that. So these are other products. We make a full line of nitrogen generators, wall units, big systems, big nitrogen, all factory mutual approved. And then we have what we call our spec developer. So if you have a pre-action application, you answer like 6 questions. Do you want single interlock or double interlock? Do you want nitrogen? And it'll basically create for you a particular specific specification in master spec format along with CAD drawings. So if you ever want help with that, writing specs, give us a call and we can whip out specifications very, very quickly for you. And that concludes the presentation. I want to thank you very much for your attendance and attention today. I'm under my allotted 1 hour, so I have to give myself a pat on the back for doing that, not overrunning anything. Any last questions before we wrap it up?
Brian, anything from you?
Actually, no. Thanks for the insight into this system.
Yeah.
You're welcome. And like I said, feel free to, when you get questions or applications, Brian, you can reach out to Aaron and he can help you, and he can reach out to our engineering staff. And, Steve and Cody, you do the same thing. If you have specific questions, and, we probably know more about water mist than any other company in the United States. I hate to brag like that, but we've probably done more. And it's something that's been a passion of mine for probably since the old Halon 1301 days. I recognized water mist as being a long-term sustainable solution, and it's turned out to be true.
Okay, I'll definitely keep you guys and keep Aaron and informed and everything, see what's going on. Because the only thing is, I don't know, I would have to, the main thing like down here in Florida, it's not a lot of people are going with the water mist, so it's still new.
Mm-hmm.
So it's sort of like we got to get everybody to adapt to it.
The way I look at it, the way I look at fire protection and suppression agents is that, you have to have, your bag of tools. Okay. And, you've got clean agents, you got dry chemical, you have fixed aerosol, you have CO2. You have sprinklers, deluge, water mist. They all have their strengths and weaknesses. And the story I gave you about the medical facility, if I didn't know about water mist, I could not have solved that problem for that medical facility. We would have been digging up the highway. So, sometimes, sprinklers are better for whatever reason. There may be a cost issue, or in the case of, say, central storage batteries, that's your solution. So you just really know, I'm not really like a big promoter that, hey, it's got to be water mist or anything. It's just one of our, things in our bag of tricks that we have to our disposal. And that applies to also detection technology. You have to be knowledgeable in all the various detection technology that are coming down the pike. You've got spot high sensitivity detection, VESDA, you've got now thermographic imaging that's coming on the scene. So knowing all these different tools helps you select the best detection, the best suppression, and then you put it all together in a unified system along with the interfacing with HVAC controls and things like that. It's a total systems approach. But again, knowing that this exists and what you can do with it is the first step in solving problems for your customers.
Very true.
Hey, Tom, Frank, sorry. Thanks. I gotta
Okay.
drop. I appreciate
Yeah,
it.
thank
Okay.
you very much.
Bye now. Thank you
Right.
again. Bye.
Thank
Thanks,
you.
everyone.
All right,
Bye.
bye-bye.